So today we'll see how to evaluate the limit of exponential and logarithmic function. So today we'll see how we can evaluate the limit of a function involving exponential and logarithmic function. So before that we'll discuss the key formula or the governing formula, that is okay. So we can also write log e to the base a is also written as ln a. So now we'll generalize this formula, that is limit x tends to a to the power f of x minus 1 divided by f of x is equal to log e to the base a. When so when this condition will hold, we can say that the limit of this one will be log e to the base a or ln a. Now we'll see another. Okay, let me explain this with the help of an example, that is okay. H limit x tends to 0. Here f of x is, we can clearly see that f of x is here 5x. So 5 of x is equal to 0. So that's why we can say that this will hold. So now we'll see another formula involving logarithmic function, that is so we'll generalize this formula, that limit x tends to a is equal to 1 when so if this will hold, then we can say that the limit of this function will be 1. Okay, With the help of an example, we'll see that limit x tends to 0 h limit x tends to 0. Here our f of x is sin x is equal to 0. That's why we can say that this will hold. Okay, so we'll pick some good questions and discuss their how we can evaluate them. And before that, I would like to write one another formula, that is limit x tends to 0 e to the power x minus 1 by x is equal to 1. Okay, h in our previous result we have to take log e to the base a, that is log e to the base, here a is e, so log e to the base e is 1. So it is very clear. Now we'll pick some problems. Log 1 plus x divided by 3 to the power x minus 1. So I will divide the numerator and denominator by x. Okay, then after that I will just write I'm just using the algebra of limit. So from here can again like write here. So it is the standard result that we have derived in above. So it will be 1. So the limit of the numerator function will be 1, and the in denominator it will be log e to the base 3. One can write it ln 3. Again we'll see uh, some different question. So we'll see some different question, that is minus 1 divided by b to the power nx minus 1. So here we'll divide the numerator and denominator by x. So in order to apply the formula that we have derived above, we just have to make sure that the question is in the standard form, that is here if we can, here we identify that it is in numerator, it is the f of x, but in denominator it is only x. So in order to make the denominator f of x, we'll multiply the numerator and denominator with m. Similarly, in denominator function, we can see that it is nx. It is our required f of x. So to make this f of x in denominator, we'll multiply it with n. So it will be, here we'll multiply n, and here we'll multiply n. Here we'll multiply m, and here we'll multiply m. So it will convert to limit x tends to 0 m e to the power mx minus 1 by mx. It is n b to the power nx minus 1 by nx. So the limit of this one will be log e to the base a, and the limit of this one will be log e to the base b. So the reduced result will be m log e to the base a divided by n log e to the base b. That's all. Now we'll see some another question. That is limit x tends to 0 log a plus x minus log a minus x. So before this, I would like to write one formula, that is log a into b. We can write it as log a plus log b. So I will take a common from this expression, so it will be a into 1 plus x by a. So I will write, so here I will apply, here I will apply this formula. Here a is a, and 1 plus x by a is our required b. Okay, so I can apply log a into b. Then it will be reduced to log a plus log 1 plus x by a minus log a, okay, minus log 1 minus x by a divided by x. So we can cancel out log a minus log a. Then the reduced expression will be limit x tends to 0. It will be log 1 plus x by a minus log 1 minus x by a divided by x. So I can further write it as log 1 plus x by a divided by x minus log 1 minus x by a divided by x. So in order to apply the standard formula, logarithmic formula, we have to identify the f of x. So here our f of x is this one. In this problem, f of x is it will okay. So make this, write this plus, and it will be minus. So our required f of x is f of x. So we have to make the f of x in denominator as well. So what I will do, limit x tends to 0, log 1 plus x by a divided by, here I will multiply a and divide a, it will be x by a. So, and when x tends to 0, x by a also tends to 0. Then we can apply our standard formula here. So to make the f of x in denominator, we will multiply here plus and take this minus to the minus x. Log 1 plus minus x by a, it is minus x here. We have divided a and multiply a with a. Then this limit will be 1 and limit of this one will be 1. So the reduced, the rest of one here will get, from this term will get 1 by a plus here will also get 1 by a. So it will be 2 by a. Now we'll see another question. That is, so clearly you can see that in this function we have to use the exponential formula due to this part, and here trigonometric function is also involved. So we'll use the standard trigonometric formula as well. So x to the power x minus 1, what I will multiply 1 plus cos x in the numerator and in the denominator. So it will be reduced to 1 plus cos x so I will apply here a plus b into a minus b. It will be reduced to a square minus b square. So in next step it will reduce to the power x minus 1, okay, 1 plus cos x divided by, okay, 1 minus cos square x, and 1 minus cos square x is sin square x. So I further write it as Okay, 1 plus cos x is also there, so it will be reduced to sin square x. Then limit x tends to 0. Okay, so here I will multiply x in the numerator and in the denominator. So it will be x square by sin square x into 2 to the power x minus 1 by x into 1 plus cos x. Now I will apply the due by the algebra of limit. We can individually evaluate the limit if they exist separately. So limit of this one will be 1. Okay, limit of this function when x tends to 0, it will be 1, and the limit of this function will be log e to the base 2, and limit of this one will be reduced to 2. H cos 0 is 1. So I get here 1 into log e to the base 2 into 2. So it is 2 log e to the base 2. Okay. So now we'll see some another problem. That is limit x tends to a log x minus log a divided by x minus a. So how can we solve this logarithmic function? So log a minus b will be log limit x tends to a. So when x tends to a, we can see that this form is reduced to, okay, 0 by 0, which is the indeterminate form. So we'll reduce it with log a by b. I can write it as log a minus log b, your log m minus log n is equal to log m by n. So I've written it here. So by taking x common outside, it will be x 1 minus so here if I will take no, I will not, I will have to erase here. I will take minus a outside, and it will be minus a 1 plus, sorry, 1 minus a, then it will be 1 minus it will be 1 minus x by a. Then it will be limit x tends to a 1 by minus a into log, okay, 1 plus minus 1 plus x by a. I can write it as same. So 1 minus x by a is here. So what I will do? I will do limit x tends to a minus 1 by a into log 1 minus x by a. So okay, so I have here hmm, no, I have to mm, yeah, it will work. Yes, so yes, it will work. Okay, so limit x tends to a, it will be minus 1 by a into, just to make sure with the to match the our standard result, I will take log 1 plus, it will be x by a minus 1. So in the denominator it will be, I will take minus common outside, then it will be x by a minus 1. Then it will be, I will take here minus 1 by a into minus 1, it will be 1 by a outside. So it will be limit x tends to a log 1 plus x by a minus 1 divided by x by a minus 1. So here we can clearly see that our f of x is this one. Okay, so here you can see clearly that our f of x is this one, and in the denominator also we have f of x. And when x tends to a, this f of x tends to 0 as well when x tends to a. So I can apply the standard result, and by applying this we can say that the limit of this one will be 1. So it will be 1 by a into 1. It will be 1 by a. Okay, so now we'll see some another problem. That is limit x tends to infinity. I have x e to the power 1 by x minus 1. So limit x tends to infinity, it will be e to the power 1 by x minus 1 divided by, I'm taking the x to the denominator, then it will be 1 by x. So if we match to this format, the standard one, then we can easily evaluate that here is 1 by x is our required f of x. When x tends to infinity, 1 by x tends to 0, and 1 by x is our f of x, means f of x is equal to 0 when x tends to infinity. So I can apply the standard formula, and by applying it we can say that the limit of this one will be log e to the base a. Now we'll see one easy question, that is limit x tends to 0 e to the power sin x minus 1 by x. So what I will do, in order to apply the exponential formula, I can clearly see that the f of x will be sin x. If I will divide uh, the numerator by sin x, then I will apply the standard formula. So limit x tends to 0, it will be sin x by x into e to the power sin x minus 1 by sin x. So limit of this one will be what, 1, and limit of this one will be also 1, as here f of x is sin x, and when x tends to 0, sin x also tends to 0. That's why it will be 1 into 1, it will be 1. Now we'll see another question. So we can write 8 as 2 into 4. I'll write 8 as 2 into 4 power x minus 4x minus 2 to the power x plus 1 divided by x square. So from the basic mathematics we know that a into b to the power x, okay, we can write it as okay. So that's why I will write it as so. From the numerator I will take 4 to the power x common, and it will be 4 to the power x, 2 to the power x minus 1. Now I am taking minus 1 common, and it will be 2 to the power x minus 1. Then now I will take 2 to the power x minus 1, this one common from this term and this term. Then it will be 2 to the power x minus 1, 4 to the power x minus 1 divided by x square. Further I will write it the above as 2 to the power x minus 1 by x into 4 to the power x minus 1 by x. So limit of this one will be log e to the base 2, and limit of this one will be log e to the base 4. Log e to the base 4. Then it will be, that's all. This is the final result.